Thank you all for joining. My name is Dotan. I'm the co-founder and the CTO of the Guild. I'm pretty sure you all already heard about the Guild here. I don't have a lot of time, so I'll just share the way that we work with companies and the way that we build open source. So basically, the Guild is doing and developing and maintaining a lot of open source libraries. And the way we operate, we create open source libraries and projects. Then companies and startups and partners are reaching out to get help and support, and they have questions. And based on this work and the collaboration with others, we are feeding that back into open source. So this is, we call it a cycle, because from open source, we feed that into companies, and then this feeds back into open source. So based on this experience, and from the work with many companies, I'm going to talk today about GraphQL gateways. I have a few topics here. I really hope that I'll have enough time to talk about all of them. I'm not sure I have, but I'll try. So I'm going to start quickly with the GraphQL adoption path. From the point of view of how we saw it so far in the past few years of working with companies and doing consultancy. So there is no one way of doing GraphQL, but let's try to summarize that. So usually when companies start with GraphQL, it's like this new cool thing that you heard about, and you're just starting with building your GraphQL server. You're probably using a database, connecting to a database, fetching some data. GraphQL is your only client at that moment because you just started with it. With time, you get this one new client and you're happy with it, and your GraphQL server actually gets some traffic. This becomes cool and people start to hear about it. Then there is this mobile app that also needs the same data, and they heard about GraphQL and they also want it. So you get more traffic coming, you have more consumers to the GraphQL endpoint, and you probably start at this point to connect more data sources, and data makes more sense because it's connected. At this point, we saw in many companies that there are two paths. One is that you are very happy with your GraphQL monolith, and you decide that it's fine to do GraphQL or many GraphQL servers, and everything might work just right. There is the other way of doing it as this one graph approach of building this federated schema, composed schema, stitched schema. It has like a lot of names, but the idea is that you might have more than one GraphQL server. At this point, you're already connected to more data sources. This is usually the point where your IT or your managers starts to ask questions. What is this new shiny thing that you just deployed on our cluster? How do you keep it secured? How do you even scale the development process of that? Do we need to share anything between these two teams that are doing GraphQL? Because if it's just GraphQL in two teams, why not share and do things together? And the last question is, how do you make sure that the entire company can benefit from the effort that you're putting into building GraphQL? And this becomes more complicated, and usually this is where GraphQL gateways are appearing in your architecture. It could appear in many different ways. It might be part of the general architecture based on the specification that you chose. If you're using Apollo Federation, for example, or you are going to use Fusion in the future, you're probably going to use a gateway that matches the specification that you picked. At this point, the gateway can help you and probably offload some of the things that you did before manually. If you were composing things in your CI or trying to make sure that all of your subgraphs somehow match together, at this point, the GraphQL gateway takes this role of making sure that everything works. Uri was talking yesterday about this big picture where you also fit into the schema registry and you get the artifact and the supergraph, and things just become more complicated. So at this point, you already have a gateway. But I think it's very important to talk about what is a gateway and what it can do for you, what it doesn't, and later we'll try to answer some questions, and I'll also share a bit on the work we did to evaluate and try different gateways. So a GraphQL gateway is, first and foremost, it's a proxy. I didn't mention HTTP proxy here on purpose. I'm sure that some of you already heard about GraphQL over the internet. Dennis talked about it yesterday. And the idea is that it's a proxy, but it doesn't have to be an HTTP proxy because there are different transports. You can use HTTP, you can use WebSockets, and the list just goes on. We even heard at some point of a company that tries to do GraphQL over TCP with binary data over the wire. You can pick any transport you want because it's just a protocol. So it's a proxy to do many things. If you're using HTTP, you might do some headers validation, manipulation. You might want to do HTTP-based caching. Dennis also talked about how you can do GraphQL over GET operations and leverage the built-in mechanism of caching that exists in a browser. So the list goes on because a GraphQL gateway can even do error handling. This is your entry point and the point that delegates all the other calls later. So you can do observability at this layer, understand the actual usage, and even do monitoring. One of the other important thing about a proxy is that you might at some point need to have clustering feature because you don't want this new shiny piece of architecture to be a bottleneck in your architecture. All of the GraphQL requests are going to flow this piece of architecture, so you want to make sure that it's easily scalable and it's not going to fail, let's say, on Black Friday. A GraphQL gateway is probably also a GraphQL router. Depends on what you pick. And this means that you basically take a GraphQL query, you're trying to route it into the right place, but the right place might not be just one GraphQL server. It might be more than one. So either if you're federating or not, eventually you are going to do some kind of routing. So it could be with a distributed GraphQL execution if you're using federation. You might want to do some query planning. It doesn't matter if your upstream is a GraphQL service or a database. Arda was showing how Mesh can do amazing things and just take the GraphQL to the extreme by converting databases. Also PostgreSQL is doing that, and Hasura, converting databases into GraphQL. So query planning is important at this layer. You can also understand what's going to happen under the hood by explaining the actual plan and checking and validating that the calls that are orchestrated are actually correct and make sense and efficient. And last, schema filtering, because this is, again, your entry point. So if you want to even filter your schema, let's say, break your schema to pieces again, we saw many use cases where companies federated the entire GraphQL layer into subgraphs, and then the gateway actually took that one unified layer and broke it to multiple pieces again. Private API, public API, partners API, things like that that are also relevant to do. So filtering or manipulation of the GraphQL schema is also happening at this layer. One other use case of routing is to do this concept of many-to-many. You can take the GraphQL schema and expose it, the same schema, in multiple ways, not just filtering it or changing it. Let's say that you want to expose a public API with a JWT, but you want to expose the same schema over a different endpoint with a different mechanism of authentication. So this is also an important piece that happens on the gateway level. So a GraphQL gateway is also an extension layer. We saw many different solutions that are solving this one specific problem or several problems for GraphQL. I listed here this list. I won't dive into the details of each one, but things like caching, authentication, authorization, security, hardening your GraphQL API, doing validation, policy validations like depth limit, cost limit, complexity limit. The list just goes on. And these are features that are not really part of the GraphQL specification. They're just an added value that companies just need to make sure the GraphQL gateway, their GraphQL layer is actually correct, valid, and works the way that they want. I'll mention here tracing and metrics because as this entry point of your queries, you might want to do tracing and make sure that you are on top of what's going on with your GraphQL layer. Persistent operations is also very important. I'll talk about this topic in a few minutes when I'll talk about public versus private APIs. So I started this overview because 6 months ago, Uri and I was talking and we tried to answer this question, the title of my talk, how to choose a GraphQL gateway. And we didn't have the answer, so we started this process of trying to list all the available GraphQL gateway, list all of their features, all of their features, issues, ideas, concepts, future things that might be supported later. And we also tried to benchmark and understand how people pick a GraphQL gateway, and do they do that based on performance? So in this process, we created a repository. If you scan the QR code, you can see, you can get to that repository. We created a repository that benchmarks GraphQL gateways and tries to summarize the big picture of performance when it comes to GraphQL gateways. It's a very comprehensive one, so I don't have enough time to go into all the details, but I do encourage you to scan the QR code that I'll show it again in a second. You can find there a lot of meaningful information, starting with RPS, timing, duration, memory, CPU, and a lot more. I'll just scroll through, and I wanted to share a bit on this process and how do we implemented this benchmark repository. So first we tried to evaluate which distributed GraphQL specifications are supported in every gateway. Is it Federation, Federation 2, maybe Fusion, maybe schema stitching? We tried to list all of that. We tried to understand, is it a product or a library? What is the actual usage of that gateway? We listed, as I said, all the supported features and did this huge metrics of gateway to feature, and it's like an endless list. It's also part of the repository. You can find it there. We also tried to make it fair and neutral. And to do that, we reached out to companies who are actually building the gateways and asked them, what is the best practice? How should we run your gateway? What resources it needs to run, and what configuration should we use to get the best and the most out of that gateway? And last, we asked ourselves, how can we make sure that this benchmark is up to date? Because we don't want to just introduce another benchmark that uses old versions. It's not up to date. It does not include all the new features. So this is what we did. I'll share a bit on the decisions that we made for this benchmark. And then I'll share what do we want to do next and how you can help us with it. So we picked the enterprise use case. That means it's not a simple GraphQL server. We used several subgraphs, and we picked the Apollo Federation v1 specification for that. There is a new one, of course, the V2, but we picked V1 because it's more widely adopted. We implemented the subgraphs in Rust to make sure that they never become a bottleneck and they don't affect the gateway performance. We asked our partners and customers, what is your scenario? What are your scenarios? What do you run in production? What are the actual issues that you're having to understand what are the scenarios that we're going to replicate in that benchmark? We also picked a wide range of runtimes. We didn't want to pick only the popular one. We want to check also the relevant ones because Rust is very popular now and Go can bring this extra added value of quick development with amazing performance. Node.js is also great and Bun is the new hot thing going on. So we tested all of these. And I mentioned before that we want to build this as a fair and neutral benchmark. We built this CI pipeline that runs all of these gateways in a very isolated environment. We're using different sets of resources. We're trying it on 1 CPU, 2 CPUs, 4 CPUs, and a wide range of configurations, just to make sure that we're not missing any important detail. I'll also mention that right now we're using GitHub Actions, and it yields pretty stable results, but very soon we're going to, with the collaboration with Chili Cream, we're going to run these benchmarks on bare metal machines and have like a dedicated physical machines to run these gateways, to run these benchmarks to make sure that we always get stable results and nothing, there are no like noisy neighbors or other issues affecting the results. So I said it, I mentioned how you can help us. So we are trying to build this real, fair, neutral benchmark. So if you have ideas, if you have scenarios that you want to share with us, or maybe if you're building a gateway and you want your gateway to be listed in that benchmark, reach out to us because you can create a PR. It's very easy to add your own benchmark. It's just a matter of adding the Docker image and it's there. But you can also open an issue. It's fine, and I'll do it. And yeah, if you have a very interesting use case or a scenario that you're experiencing in production regarding performance or even bottlenecks that you're trying to spot and find, reach out because we can try to build this together. So this brings me to my actual question and the title of this talk, how to choose a GraphQL gateway. So to answer that, and I can promise that you leave this room with an answer, maybe just more questions. So I collected a list of questions that helped me and our customers to pick a GraphQL gateway. So I'll start. So first, you might want to ask yourself, are you building a private API or a public API? Or maybe both, it's also fine. Because if you're building a private API, you can leverage things like persistent operations. And you might have less limitations when it comes to security if your GraphQL API is internal to your company or cluster. In private API, you can also have predictable traffic. You can know ahead of time who are your customers, who are the clients, and what are the queries that are going to execute. If you're building a public API, it's a whole new story because with a public API, the traffic is unpredictable. You don't really know what queries are going to come. For sure, you're not trusting any one of your clients, and security becomes a serious issue. And in general, when you're building a public API, you're going to think more about your schema and the way that users are consuming it. So this is question number one. The next question is, are you building a monolith schema or a distributed schema? And this is an important question because your answer might narrow your choices. We have like several different specifications for creating distributed schemas, and each one that you pick might dictate what router or gateway you can use. So that's also a question. I mentioned here the monolith schema because I do believe that this is also a valid use case. I don't think that when you grow to several teams working on your GraphQL layer, you must federate everything or build everything in this architecture that splits your GraphQL to multiple pieces. It doesn't have to happen, and it's all about how your team communicate and how people are working together. The next question is, which distributed schema specification are you using? Because if you picked, let's say, Apollo Federation, you have a wide range of gateways that supports it. You can use GraphQL Mesh, you can use Apollo Server, you can use Apollo Gateway, and you can use Apollo Router. WonderGraph also supports that, and also Cosmo. So you have a wide range of tools supporting it. You might pick Fusion. Fusion is going to be the next amazing specification for distributed schema. So this might also affect your choice. There is also schema stitching. Schema stitching is relevant and it's performant than ever. So if you want to use schema stitching, you can use GraphQL tools and build your own gateway, or you can use GraphQL Mesh and have it on the fly. The next question is, do you prefer a product or a library? Because if you are fine with a product, then you might just fit a configuration into it or a super graph, and you just get a gateway working out of the box. But if you're looking for the flexibility, you might want to pick a tool that allows you to hook into different phases, add your own custom code, have full control of the execution, and this way you build a custom gateway. The next one is, do you have feature requirements? And feature requirements can really dictate what you're going to do. If you're going to build a gateway or run a gateway publicly, and you might need features like rate limiting, you might need a gateway that knows how to natively implement rate limiting over GraphQL. There are more features like caching, and I mentioned persistent operation, which are also a very important thing when you're running gateways. So feature requirements is also very important. I'll talk about this topic in a minute a bit more. And the last question for today, do you have performance expectations? And the reason I'm mentioning it is because of the benchmark, because what we learned is that, and I'm sure that everyone knows it here, is that memory and CPU cost money, and it costs a lot of money. If you have a very efficient gateway that doesn't require a lot of resources, it might be easier for you to run. But if you're just building your hobby project or a startup or medium-sized company, you might not need a gateway that performs just with 8 CPUs, for example. So I have here one of the screenshots from the benchmark that we did. I'll talk about this real quick. You can scan the QR code for the repository and see the list of all the scenarios that we built and see the results, and please share with us if you have more ideas. So as I mentioned, we picked the Federation V1 scenario, so I'm sharing this here. I'll just focus on the top 3. So we have here WonderGraph, and we have Apollo Router that seems to perform very, very well and in a very similar result. We also, when we started this process, we took GraphQL Mesh and the Node.js implementation of it, and we took it to the extreme. Arda did amazing work on replacing the HTTP layer to be able to handle an insane amount of requests, and you can see from this result that just by improving Node.js, we managed to get a far better result than the rightmost gateway here. So if you want to take a look at the results, go to the repository. It's all there. This brings me to the next topic. When we started this process, we asked ourselves, how do we choose a GraphQL gateway? And our answer was not, I would say, we didn't have like a clear answer on that after 6 months. So the Guild is building a conductor. Conductor, I'll briefly mention what we're building and how we are building and why we are even building this. The name is, the origin of the name is from an electric conductor that basically takes a current and then sends it to the next station. So this is what we're going to build with conductor. So we are trying to build this gateway that will serve all kind of GraphQL use cases. We're building it as a GraphQL first gateway. We're trying to focus on what GraphQL, the core implementation of GraphQL does, and add some added value on top of that. It's going to be full open source, as anything else we're doing and building at the Guild. We want to build Conductor with community-backed specifications, and that means that every feature that we're going to implement in Conductor, we are going to start a discussion with the community on how should we implement it. Because there are many ways of implementing, for example, caching in GraphQL, but we want to make sure that the caching mechanism that we're building fits as many use cases as possible. We started a new repository to collect ideas, use cases, and in general features for a GraphQL gateway. So if you have any, there will be another QR soon that you can scan and just share all of your ideas with us. So I don't have a lot of time, but I'll share quickly why we're building Conductor. So we do want to push the GraphQL community forward, and we're not trying to push for one specification or one way of doing GraphQL. We're just trying to push the GraphQL implementation itself to the extreme. We do believe that GraphQL itself at the core is great, but in real-life scenarios, you need a lot of things on top of it, a lot of features. So that's what we're trying to implement. We're not going to make Conductor proprietary in any way. It's going to be real open source, no vendor lock. And the best thing, it fits into your existing stack. So if you're already implementing GraphQL in your company or building your GraphQL server, you can just use Conductor in front of that. So yeah, that's all with Conductor. We are going to share more in the next few weeks and launch the alpha version of it. So if you're interested, there's this QR for signing up for the alpha. And if you want to share your use cases and ideas with us on what you need from a gateway, we have this repository of specifications that we are going to share everything we learn about GraphQL and GraphQL extensions in. So yeah, we would love to see you there. So yeah, thank you, and I really want to say thank you for everyone at the Guild, all the Guild members, because yeah, they are the ones who are doing all the amazing work. That's all. Thank you. I have 1 more minute for questions.
Will Conductor support Federation V2 and/or Fusion?
So yeah, I mentioned that it's GraphQL first, but we do want to support both Federation, V1 and V2 through the SuperGraph protocol, and also Fusion. Oh, that's a perfect question. So, so the question was, how does it relate to mesh? So, I think that it really depends on what you're trying to build, because mesh has amazing capability for operating as a GraphQL gateway, and it also brings the added value of converting everything to GraphQL. And on top of that, it brings the option to control your schema, the generated schema from all the sources, and you can extend it very easily. I think we're going to build a Conductor in Rust, by the way, and we think that when you put this very crucial piece of architecture as your entry point. You need to be very efficient, and this layer needs to be lightweight and do one thing and excels in that. So that's what we want to do. And feel free to check out Mesh. I mean, it does that right now and don't need to wait this extra few weeks. Thank you.